Hi. This is a demo of the traffic simulator SUMO and its related packages for editing road networks, as well as a demo of how to use traffic control interface, aka TraCI, which gives us access to running SUMO simulation so we can dynamically modify stuff like vehicle states and do things like reroute vehicles and query the simulation state while the simulation is running. We'll talk more about TraCI later, but we're going to start just by building a simple network in NetEDIT. So I'm going to assume you have SUMO and its corresponding toolkit packages set up and installed, because we're going to start with NetEDIT. Okay. So NetEDIT is a graphical network editor for SUMO, and it makes our life a lot easier. We can manually create these networks explicitly with node, edge, and connection XML files, but it's pretty tedious. So we're going to use NetEDIT to streamline this. That way we can get into like the more fun stuff with SUMO and TraCI. It's probably a good exercise to build a simple network completely by hand. That way, if one of your junctions or whatever is behaving undesirably, you can go in and manually tweak some parameters and hopefully get it behaving the way you want it to. But I don't want this video to be 2 hours long, so I'm going to use NetEDIT, okay? This will also demonstrate some of the most basic features of NetEDIT and get you off and running. Okay, so first we need to set up a couple environment variables so SUMO and TraCI can find the necessary Python modules and program binaries for some of the stuff we're going to be doing later. So let's just find out where SUMO is here on this machine. Okay, so we'll just set our environment variable here. SUMO home. Okay. Now we'll start at NetEDIT. Okay, so we want a new network here. We're going to switch to edge mode so we can just create a simple network. So click E. We'll click chain so we can, each node connects itself to the previous one automatically. Makes it a little easier. Zoom out a bit here. Okay, so let's just make a little circle. Okay, so boom. Not pretty, but that's all we need. And we'll connect it there. Okay, so I zoomed out a bit and added another edge here. We're going to use it later when we're rerouting vehicles with TraCI. Okay, so let's go to inspect mode. So you click I. Let's just rename these edges to something more manageable. So when we're tweaking some stuff in our XML files, they got some nicer names to work with. Okay, let's give each edge, we'll make them 3 lanes. That way we can see how the behavior changes when vehicles are trying to pass and stuff like that. So you could set up a Python script to do some of this stuff for you, but I'm just going to show you how to do it manually for now. So we'll save this. Call this demo.network.xml. And you can see NetEDIT adds all its connections and junctions automatically for you. Okay, so I've opened that network XML file that NetEDIT created for us. And even though it's a simple network, you can see all this stuff in here. So it really does make our life a lot easier. So the next step is to make the SUMO config file. And this is the file that you will load itself into SUMO. So it knows which files it needs to load and that stuff. So here's the basic skeleton. since we only have one file made so far, that's our network file, we're just going to add that in here. Okay, so save that. Now we're going to open SUMO and open this config file that we just made. Okay, so there's our network. Now I'm going to run this, but since we have no vehicles or anything else in here, it shouldn't do anything. So there we go, all vehicles have left, not much going on. So next step here is to add some vehicles. Okay, so we need to make some vehicles here. So we're going to create another file called demo.rou.xml. This is our routing file. This is where we specify stuff like our vehicle types, their properties, as well as the routes they're going to take throughout our network. You can find all the different vehicle types in the SUMO documentation. We're just going to use two. We're going to use just a passenger vehicle and emergency vehicles. These basically work, these classes parameters here work as just basically a shorthand, because they specify certain default behaviors. So we don't have to specify each property ourselves, because there's 20 to 30 different properties here we can specify. We're just going to use about 5 beyond the default. So we'll set our passenger length a little smaller than our emergency vehicle length, and we'll let our emergency vehicles accelerate faster. This sigma value here is just a stochastic component which just adjusts. It's a randomization to adjust how fast they move relative to the speed limit, because you don't want each vehicle moving exactly the same, because that's not very realistic, and that would not make for very interesting interaction, as they'd all just kind of stay the same distance behind each other. So this adds a little bit of randomization. We're going to set our sigma value to 1, so they vary up to the posted speed limit in our network file. This makes our life a little bit easier. Okay, so we're also going to set the max speed of our emergency vehicle a little quicker. We can specify its GUI shape. This is so we can visually see a difference in SUMO itself. And we're going to change the speed factor here to double. This way they can essentially break the speed limit, which is often what emergency vehicles will do if they're able to do so safely. So we're going to also set the minimum gap here for lane changing, so that they can make riskier lane changes than might otherwise happen by default. Okay, so now that we have our vehicles set up, let's specify a route for them to travel. So we're just going to call this route 0, and we need to specify the edges that it's going to travel explicitly, each edge. So we'll just go through our edges here. So we have E0, E1, E2, E3, E4, E5, E6, E7, E8. So that's just the circle of our network there. Now that we have a vehicle type and our route specified, let's create an explicit vehicle that will travel this route. So we'll just call this vehicle 0. We'll make it a type car here. Oh, sorry, that should, oh yeah, type car. And it will travel route 0. And we'll make it depart at simulation time 0. Now that we have our vehicle route set up, we need to add our route file to our SUMO config. So we need to specify our route files. Since we only have one, we'll just have one value here. And it's called demo.route.xml. Okay, so now let's run SUMO, see if we have our vehicle. Okay, so we're gonna turn the delay up a bit so our simulation doesn't end in 2 seconds. Or less, I guess. Okay, there's our vehicle. And it ends there because we only specified that one route. As soon as it hits the end, that's the end of the simulation because we have no more vehicles being added. Okay, so we explicitly defined our path. Have to give it each edge. There's another way of doing this, and it's called SUMO Flows. SUMO by default uses Dijkstra's algorithm to route paths, so we can actually just give it a start edge and an end edge. So we'll start one for our passenger vehicles. We'll call it car flow. We'll have 5 cars, so we can make as many number of cars we want, and we can specify begin and end so we can keep this going for the whole time. But we want to use the same 5 vehicles so we can adjust their behavior later on. So we'll just use 5 for now, and we can just specify they're starting at edge 1 and ending at edge 8. Okay, so we don't need this vehicle flow anymore, so we'll comment that out. And let's run SUMO again. Okay, so let's okay, so we have a flow now of our 5 vehicles, but what we really want them to do is keep going in circles so we can analyze their behavior when we modify certain parameters and when we start playing around with TraCI later. So what we need to do is create an additional file. This allows us to add components like rerouters, which is what we're going to use to keep these vehicles moving in circles, and things like induction loops or detectors to gather information about certain lanes or vehicle speeds and stuff like that. So what we need to do is create an additional file. We'll call this demo.add.xml, and we're going to add 2 rerouters. The first one's going to be on edge 1, and that's going to just simply reroute to the next edge. And then when we hit edge 2, it's going to reroute all the way back around to edge 1. So this will essentially keep them going in a loop. And we'll set the end time to 10,000 simulation time steps. So it's not going to go on forever, but this is effectively long enough to start testing some parameters when we start playing around with TraCI. So now that we have our additional XML file set up, we need to do what we need to have done every time and add it to our SUMO config file. So this is an additional file, and we're just going to have the one again, and it's called demo.add.xml. Okay, so let's open SUMO up again, and now that we've reloaded it, we can see that we have 2 rerouters here. So let's run our simulation. There's our passenger cars. Now you can see they're going in a circle, which is what we want, and this will continue until we hit 10,000 time, which is long enough for us to mess around with it. Okay, so let's just add one more flow, but this one for emergency vehicles. We'll just have one emergency vehicle though. So let's open SUMO again. We can change the visual representation here. I'm sure it's a little more computationally expensive if you're doing this with 20,000 vehicles, but it should be negligible here with just 6 vehicles. Okay, so there's our 5 cars, and there's our 1 emergency vehicle, and you can see he's able to overtake them because his speed is set quite a bit higher. Okay, so we've got this working now. Let's start messing around with TraCI so we can do some things dynamically. Okay, so now we're going to start using TraCI. So TraCI is short for Traffic Control Interface. It's an API that gives us access to running SUMO simulation. It uses a TCP-based client-server architecture to provide access to SUMO. where SUMO acts as a server and each separate TraCI program acts as a client. So in this demo, I'm just going to create one program. I'm going to use Python. There's other packages written in C++, but Python is the most rich, so that's the one I'm going to be using. Okay, so we're going to start our Python program here. This will be the program that interfaces with SUMO through TraCI. So I've already written some utility type stuff here. Just included some modules that we need. It's a little bit error checking to make sure that our environment variable has been set so that it knows where to find our TraCI modules and some SUMO libraries that we'll be using. And the main part here is going to be this function run, and this is going to contain our TraCI control loop. Down here we have our main entry point. This just checks if we specified SUMO or no GUI. And TraCI starts SUMO as a subprocess, and then the script will connect and run and interface with it. So we're going to run our SUMO binary, and this is just specifying our config file. And we're going to output some trip info from SUMO into a file called tripinfo.xml. And then we're going to run our control loop. So let's get cracking on that, because that's the important and fun stuff here. Okay, so our main control loop here. This is our exit condition. This get min expected number will return 0 when all route files have been exhausted and there's no more vehicles left in the simulation. So this is how we know when our simulation is ended, and after that we need to call TraCI.close. Okay, I think we might do some print into console, so let's just do a flush. Okay, so in our loop we need a way of actually advancing the time step. So we do this by calling TraCI simulation step. Now by default this will just advance the simulation one time step, and we're just going to keep it like that. So we probably want a way of keeping track of our time step, the current time step. Instead of, we could query via TraCI SUMO, but why go over the network if we can just keep track simply enough through here? So we're just gonna increment step by 1. Okay, now to make sure we got everything kind of running how we want, let's just print step to the screen. Okay, so we set up all the necessary stuff. You can see it's actually not that much to get TraCI up running. So let's just run this program and see if it's working. Okay, so let's just make our demo executable. Whoops. And let's run it. Okay, so this is now running through TraCI. We just click play to start it, and we'll see if we're printing out to the screen here each time step. Okay, there we go. And you can see it ended at 10,060. That's because our rerouter's end time was set at 10,000. And I guess it takes about 60 time steps for the final reroute to end. Okay, so now that we got TraCI up and running, it's time to change some things dynamically. Like right now we're not really changing anything, we're just printing to the screen, so that's not very exciting. So let's just set up a condition here. So we'll just wait till time step equals, I don't know, 100. And then we'll change vehicle state. So we'll change just maybe vehicle 1 and vehicle 3. So we'll make them go down that extra path that I added there. Okay, so we'll make vehicle 1 go to edge 9, and we'll make vehicle 3 go to edge 9. Okay, so let's see if this is working. So we'll slower time step down here a bit. Okay, so once we hit 100, a couple of our vehicles should reroute down this extra edge here. Okay, there we go. So that was done via TraCI. This example is pretty basic. We just changed vehicle state based on the simulation time. Obviously, we could use more complex triggers for this based on certain scenarios, train blockages, etc. to reroute emergency vehicles. So before we move on to detectors and induction loops in SUMO, I just want to quickly touch on how rich this API is. So I just showed one example of changing vehicle state, specifically changing lanes, rerouting. But there's all sorts of commands. So we can change the vehicle state, lane state, traffic light state, the simulation state itself. We can pull values from the simulation for all vehicle IDs, certain detector information, all sorts of stuff. So each of these subcategories has many dozens of commands in itself. So it's a very rich API. Okay, so we're going to talk quickly about detectors in SUMO. Specifically, one type of detector is an induction loop simulator. So these ones are used to gather information about which vehicles have entered a certain area or passed over a specific spot, a lane, how frequent, their average speed, all that sort of stuff. So detectors need to be specified once again in the additional file. So I've added one detector here. We'll just give it an ID of 0, and we need to find what lane we need to put it in. So let's just run NetEDIT again. We'll open our network, whoops, and we'll just pick a lane to put in. So maybe let's just pick this lane. So lane E41, and we'll see how long this lane is. Okay, so it's 60, a length of 60, so we'll just put it somewhere in the middle. So we'll put it at length 30. Okay, frequency is just how many time steps it will accumulate values for. So it will collect how many vehicles have entered, the average speed, all that sort of stuff, and it'll just aggregate them over a frequency of 500 time steps. Maybe actually let's go a little less. Let's go 300. Okay, and we can spit all this output to a specific file. So we'll create a file called detector out, and that's where we'll see all the information that this detector collects. Okay, so let's run our simulation again, and we'll see what kind of information is collected by this detector right here. So here's our output file. So our aggregation period was 500 time steps. So you can see we increment by 500 each time here. And it's just spit out some various data. More importantly, the amount of vehicles that have entered. And it's just taking some averages here, the average speed, average length of vehicle. Okay, now beyond just collecting data for the entire simulation via these detectors, we can query them in real time and see which vehicles have passed in the last time step. So I'm going to comment out this rerouting that's happening here, and we're just going to query this one induction loop, which has ID detector 0. And this command here, get last step vehicle ID, will return a list of all the vehicles that have passed over it in the last time step. Now, since our time step is increasing just by 1, chances are there's only been 1 vehicle that has passed through the detector at that time, but that's okay. In the case that we do have more, we'll store them all in the list and we'll iterate over the list. So what we're doing is iterating over our list here, and we're going to force that vehicle to change lanes. So this command just takes the vehicle ID, and this number here will be the lane. So in this case we have 1, 2, 3 lanes, so this detector is in the first lane, so this will force any vehicle that passes over that detector to switch to the second lane, if it's safe to do so. If there's another vehicle in that lane, it's deemed unsafe and the vehicle won't switch. But if the lane is free, they'll switch into that, and they'll stay in that lane for a duration of 25 time steps. So let's start SUMO and see if our vehicles are being forced to change lanes. Okay, it's a little tight right now, but you can see that last guy changed lanes after he passed over that detector. Okay, see them switching now? So this detector is sending us data through TraCI, and TraCI is forcing these vehicles to switch lanes. Now this would be useful if we want to simulate passenger vehicles yielding to an emergency vehicle that's approaching with its lights on, stuff like that. So this is just one small example of the stuff you can do by querying a detector. Like I said, there's hundreds of different TraCI commands you can use to change the vehicle state. So this is just a demonstration of how this would be done in a very simple scenario.